Welcome to the 5th video of the 6th chapter in the Crystal Clear Electronics video series. Now to conclude our topic, we will talk about diodes whose properties we have already exploited to protect the power supply input, but little is known about their operation. We've brought you a few diodes to show you. Some of them look similar, but all of them have slightly different functions. For example, there are simple rectifier diodes, Zener diodes, and so-called light-emitting diodes, or LEDs for short. But what are diodes exactly? Can you tell more about them?
Yes, let's take a close look at the diodes. The diode is an electronic component which allows the current to flow one direction only. We've seen this earlier when we used them. Let's see what the symbol of the diode is. It's easy to remember which side the anode is and which the cathode is. The symbol of the diode consists of a triangle and a line. The line with the triangle's two edges form a letter K, and that's exactly the cathode's terminal. In the following few minutes, we will focus on how the diodes operate. The most used diodes nowadays are built up from semiconductors. The semiconductors are materials which can poorly conduct current, and they aren't good as an insulator either. A material as an example is silicon. Out of semiconductors, type P and type N semiconductors are made by a special process. You can read more about this process in the written material. If a type P and a type N semiconductor are fitted together, we call this a p-n junction. For now, let's accept that the diode is a semiconductor device which contains a p-n junction. The type P side is called anode, the type N side is called cathode. Its special and important feature is that it only conducts if we connect positive voltage to it, i.e. the anode's, the type P side, voltage is greater than the voltage of the cathode, the type N side. We call the likely connected positive voltage as forward direction voltage. The diode doesn't conduct if the voltage is negatively connected, so we call this reverse direction voltage if the voltage of the cathode, the type N side, is bigger than the anode's voltage.
It's clear. But what kind of properties does a diode have?
One of the most important characteristics of the diode is the forward voltage. The diode conducts only if we connect the voltage high enough to it in the forward direction. We call this minimal voltage the forward voltage. Connecting voltage to the diode, which is smaller than the forward voltage, current doesn't flow. In every diode's datasheet, we can find the value of this forward voltage. In the case of silicon diodes, this value is around 0.7 volts. We can see a datasheet on the screen. This is the datasheet of the 1N4148 diode. The forward voltage of this diode is 1 volt, according to the datasheet. This value is given by the manufacturer for the temperature of 25 degrees Celsius and the current of 10 milliamps. In case of these conditions, the forward voltage will never be bigger than 1 volt.
Okay. And if the diode conducts, will it act like a normal resistor?
Unfortunately not. A resistor behaves linearly, which means that if I apply twice the voltage to it, its current will be twice as high according to Ohm's law. However, the behavior of diodes in the open state is not so simple. This is where the so-called forward characteristics of diodes come into play. Let's look at the diagram that is available to us here. This shows the diode's forward characteristics. If we connect greater voltage to the diode than the forward voltage in positive direction, then it will conduct. How does the diode's current depend on the connected voltage? In the datasheet, we can find the diode's forward way characteristic, i.e. a curve where we can read out what forward current will flow through the diode in case of a given forward voltage.
A nyitóirányú áram és a nyitóirányú feszültség forward current és forward voltage névre hallgatnak, ahogy a diagramon is láthatjátok.
In the figure, it's visible that under the forward voltage, current doesn't flow, so it isn't plotted. Then reaching this, the current starts to exponentially rise quickly.
Exponenciálisan nőni kezd.
And in the reverse direction, the diode will close perfectly? So there is no current flowing through?
It's a good question, and the answer is sadly no.
A dióda
The diode can conduct a little in the reverse state, and if you examine the datasheet that you can see on the screen, then we can see that the diode is able to conduct in the reverse direction a little bit as well.
képes fordított irányban is egy nagyon pici mértékben vezetni.
We call this current the reverse current.
Reverse currentnek hívjuk ezt az áramot.
The highlighted red part shows the data about this.
Ezen
The value of this leaking current is very small. In case of 20 volt reverse voltage, the leaking current is 25 nanoamperes, i.e. 0.00000025 amps. The leaking current grows slowly as the voltage rises. If the reverse voltage exceeds a certain value, then suddenly a great current will start to flow through the diode.
folyni a diódán. Ezt nevezzük a dióda letörő.
This is what we call breakdown of the diode, and this voltage value is the breakdown voltage of the diode.
Angolul pedig breakdown voltage-nak hívjuk.
The breakdown voltage of the 1N4148 diode is at least 100 volts, which is significantly bigger than its forward voltage.
Egyébként
And we have exploited this feature here in the power supply. We connected a total of 12 volts in the reverse direction, so the diode took the job smoothly and closed.
feladatot és zárt.
Are there any other kinds of diodes?
There are lots of special diodes which have unique features apart from the basic ones.
Kívül valami egyedivel is rendelkezik.
For example, such diodes are the LED, the Zener diode, or the Schottky diode.
Dióda.
Let's start with the LEDs. The LED is also a diode, short for light emitting diode in English. This is a diode which is made out of special semiconductors that emits light during conduction.
Ami a vezetése során fényt bocsát ki. Nagyon sokat
You will see a lot of these diodes in the later episodes.
részeiben is találkozni.
The symbol of the diode is shown on the figure.
Diódákén alapszik,
The symbol of the LED is based on the symbol of the diode. The outflowing light is marked with small arrows. The LEDs have the same features as diodes have. They conduct in forward direction only, their characteristics are similar, and they have reverse direction breakdown as well.
a ledek az anyagok
The color of the light emitted is specific to their material, i.e. it depends on the material of the semiconductor, whether it lights up as red, green, or white. Every LED is able to emit a single color light. For multicolored LEDs, they use more different colored LEDs.
És akkor most térjünk át a Zener diódára. A Zener diódával
You already heard about the Zener diode previously, where it was used for overvoltage protection.
használtuk fel.
It's the Zener diode's characteristics that its breakdown voltage can be determined very accurately, unlike the normal diode's breakdown voltage.
A letörési feszültséget
We can interpret the breakdown voltage on the reverse polarity connection.
értelmezni. A Zener
The symbol of the Zener diode is based on the symbol of the diode, only the line that marks the cathode looks differently.
vonal néz ki másképp.
Last but not least, let's talk about the Schottky diode.
A Schottky
The Schottky diode is a diode which consists of the junction of a metal and an N-type semiconductor.
dióda
The symbol of the Schottky diode is also based on the symbol of the diode. The only difference is the line that marks the cathode. This diode also has all the features that basic diodes have. Conducts well in forward direction, however its forward voltage is significantly smaller than the forward voltage of the normal diode, and its reverse direction leaking current is excessively low.
rendkívül alacsony.
Schottky diodes are fast switch devices because in them, charge storing doesn't happen.
Ezen tulajdonság
Because of this feature, they are commonly used in high-frequency devices for rectifying, for example, in switching power supplies.
üzemű tápegységekben. Ez volt a
This was the sixth Linear Power Supplies and Diodes chapter's last video from the 5 parts.
5 részes videója.
I want to thank Donny for his help.
I also would like to thank you. I think we've learned a lot about voltage dividers, power supplies with output regulation and input protection, and also about diodes. The curriculum can be downloaded in PDF format from crystalclearelectronics.eu and in Hungarian from kristálytisztaelektronika.hu. You can find the mobile application for Android and iOS platforms as well under the same name. You can also follow us on Facebook for the latest news and hope we can see you soon in the next video. Bye bye.
Goodbye.